Good morning, 8th grade. We are filming our first lesson in Unit 1, Module 1. And this unit is all about expressions. And so Module 1.1, we are going to be doing numerical expressions today. So let's look at our learning target. I can write numerical expressions for verbal expressions, and I can evaluate numerical expressions. The vocabulary that we are going to be learning is numerical expression, exponent, base, and evaluate. And of course, PEMDAS, which is order of operations. All right. So let's talk about what is a numerical expression. So if I write something like 6 plus 2 divided by 1, what do I notice? That I basically have a mathematical phrase, and that's basically what it is. It's a numerical expression is a mathematical phrase that contains only numbers and mathematical operations. So these are numbers, these are operations. Remember, an expression is a phrase compared to an equation, which would be considered a complete sentence because it has the equal to sign in it. But an expression is just a phrase. So it's a mathematical phrase that contains only numbers and mathematical operations. So this is a numerical expression, and some numerical expressions also contain multiplication, and multiplication can be represented in several ways, including a raised dot or parentheses. And so, for example, I can say 2 times 3, I can say 2 times 3. Okay, I can say 2 times 3 this way. I can also say 2 times 3. And I can say 2 times 3. All right, so these are all the different ways that I can represent the product of 2 and 3. But these are all numerical expressions. So now what we're going to do is we are going to translate a verbal expression. So here we go. You can see the board. All right. So we are going to translate a verbal expression now. And as you can see, what is it saying in this? It is saying translate 1 plus 8 divided by 3 into a numerical expression. So if I have this given to me, I'm just going to look at, okay, I have this one. Okay, I have plus, I have 8, okay, and then divided by 3. Okay, so 1 plus 8 divided by 3, and that is the translation. So let's try another one. So here's another one, which is translate the verbal expression into a numerical expression. It's saying 7 times 15 minus 2 times 9. So again, I am going to write this out as an expression. So this over here, this is 7 times, you can write all those different methods of multiplication that I had just shown you. So times 15 minus 2 times 9. Okay, so 7 times 15 minus 2 times 9, and this is my verbal expression translated into a numerical expression. So let's talk about an example. And here we go. So look at what it's saying. It is saying translate a verbal expression with grouping symbols. So translate the sum of 5 and 9 divided by 2 into a numerical expression. So let's translate this and see what this means. It's saying the sum of 5 and 9. So the sum of 5 and 9, okay, this over here is grouped together. And if this is divided by 2. Divided by 2. So what is the translation of this? Translation is going to be 5 plus 9 divided by 2. And this is my expression written out. And let's start talking about numerical expressions when I have the word format. Here we go. So writing a numerical expression, bowling. A person's handicap in bowling is usually found by subtracting the person's average from 200, multiplying by 2 and dividing by 3. Marley's bowling average is 170. We're going to write a numerical expression for Marley's handicap in bowling. Okay? So, if I look at that, the first step to find the handicap is to subtract the average from 200. So, what will be given as the average? Average is this much. And it said subtracting the person's average from 200. So the first step is 200 minus the average, which is 170. Next, we are going to multiply the difference by 2. Okay, multiplying by 2. So this difference is multiplied by 2. And finally, we are going to divide the result by 3. Okay, so it says I'm dividing by 3. So here is my numerical expression. Okay, so just look at that. Then let's look at a problem. Like this one. Again, we are writing a numerical expression. So, temperature. To convert a temperature in degrees Celsius to degrees Fahrenheit, multiply the temperature in degrees Celsius by 9. And then divide by 5 and add 32. So write a numerical expression to convert 37 degrees Celsius to Fahrenheit. So what's the first step that it said? It said temperature in degrees Celsius, degrees Fahrenheit, multiply the temperature in degrees Celsius, which is this. Okay, by 9. So we are going to do 37 times 9. Okay, divide by 5, right? And add 32. And add 32. And so, which answer choice are we getting for this? It is the first one, which is here. And that would be the correct answer. So, next thing, let's quickly look at this. When we are evaluating numerical expressions, an expression of the form xn is read x to the nth power. And the word power is used to refer to the expression, the value or the exponent of the expression. Okay, so when n is a positive integer, the exponent indicates the number of times a number is multiplied by itself, and in a power, the base is the number being multiplied by itself. Okay, so if I say 2 to the 5th power, my 2 is the base, and the exponent is to the 5th, the 5th power is the exponent. So the base, which is 2, I will have to do 2 times 2 times 2 times 2 times 2. So I'm multiplying the base by itself based on how many times it is raised to whichever power. Okay, so that's basically what it means. And to evaluate an expression means to find its value. If a numerical expression contains more than one operation, then of course we are going to follow PEMDAS, which is the order of operations, parentheses, exponent, multiplication and division go from left to right if only those two are left. And we have addition and subtraction, which also go left to right if only those two operations are left. Okay, so let's look at this once again, the key concepts. And the first thing that we have here, when we are evaluating numerical expression, as we talked about order of operations, and I just mentioned that, we are going to evaluate expressions inside the groupings, which is nothing but the parentheses. Next, we are going to evaluate all the exponents. So parentheses, so PEMDAS, okay, parentheses, exponent, then multiply and divide from left to right. That is the third step. And then the fourth step is adding and subtracting from left to right. So this is nothing but PEMDAS, order of operations. Okay, so let's go ahead and evaluate each expression. And as we can see that we have the base in the first one. Let's look at this. 2 is my base. 4 to the 4th power, that is the exponent. So we are going to use 2 as a factor 4 times. So this is equal to 2 times 2 times 2 times 2. So this base number, this base is raised to the 4th power. That means I am going to multiply it by itself 4 times. And then when I multiply, I know that 2 times 2 is what? This is 4 times 4, and that gives me 16 as my answer. Okay, let's evaluate the next one. So we are going to use 4, which is my base, and I am going to multiply it how many times? 1, 2, 3, 4, and 5, because it's raised to the 5th power. So I'm using 4 as a factor 5 times, and when I multiply this, I get 1024 as my answer. Okay, now let's evaluate this. Now we are getting into the order of operations. And if I look at this one, let's see what I have over here. Okay, do I have based on PEMDAS, which is order of operations? And what does the P stand for? This stands for parentheses. Parentheses. What does E stand for? Exponent. This stands for multiplication or division, and it goes from left to right. And addition and subtraction also goes left to right. Okay, this and these goes left to right if only those two operations are left. Okay, so now let's evaluate this. Do we have parentheses over here? Do I see parentheses? No, there's no grouping going on. So do I have an exponent? Yes, I do. So that's the first thing I'm going to do. And I've taught you in the past, always try to bring it down like this so that it gets narrower and narrower, it's organized, and go step by step by step, and then you circle the answer at the bottom. Okay, so I'm going to say 20 minus 7 plus, we have an exponent, and 8 times 8 gives me 64 minus 7 times 11. All right, then let's look at the next thing. What do we have? Multiplication? We sure do. So we have multiplication or division. That is the next step, right? So we do have multiplication. So we are going to multiply 7 times 11 next. Okay, and so we have 20 minus 7 plus 64, right? And negative 7 times 11 is going to be minus 77. Next, what we are going to do is we have only addition and subtraction. So we are going to follow the principle of going from left to right. So we are going to subtract 7 from 20, and we get 13 plus 64 minus 77. Next, we are going to add 13 and 64. And when I add 13 and 64, I get 77 minus 77. And what is 77 minus 77? I get 0. And this is my answer, which I'm going to circle. All right. So let's go ahead really quick and discuss the steps which are required for order of operations in the correct order. So once again, what is the first step? So we are going to evaluate expressions inside grouping symbols. Okay, so evaluate expressions inside grouping symbols. So that is my first step. So basically I'm doing everything which is like in parentheses first. Next, I'm going to do exponent. So evaluate all powers, all powers. That is my second step. My third step is multiply and or divide from what? Left to right. From left to right. And my last step is add and or subtract from left to right. So these are the basic steps of following the order of operations. Okay? So now let's do an example. And we have a question like this. It is saying, write and evaluate a numerical expression. So in the arcade, Melly is playing a bowling game at an arcade. She rolls 2 balls into the 30-point hole. So 2 balls in a 30-point hole, 4 balls into the 20-point hole, and 3 balls into the 50-point hole. So we are going to write and evaluate an expression to find Melly's total score. All right. So if I go over here, I am going to first complete. We are going to complete the table, or I'm just going to write it out to show you if I have this to find Melly's score. Okay, so we have 2 balls rolled into the 30-point hole. So what would the expression for that be? Here. Okay, so we have 2 balls rolled into the 30-point hole. So we have 2 times 30 plus 4 balls rolled into the 20-point hole. So it's 4 times 20 plus 3 balls rolled into the 50-point hole, which is 3 times 50. Okay, so once I have that, all I'm doing, so that was the first part, is writing it out as a table. And then all I need to do is I am going to evaluate it. And what is 2 times 30? 2 times 30 gives me 60. Plus, what is 4 times 20? That gives me 80. Plus, what is 3 times 50? I get 150. And when I add them all together, I am going to get 290 as my answer. So Melly scored 290 points. All right, so let's look at this one. Write and evaluate a numerical expression again. And it says a computer technician charges a flat fee of $50 plus $25 per hour. On Monday, he worked on Aka's computer for 2 hours. On Tuesday, he worked on Aka's computer for 3 hours. How much money does Aka owe the technician after you are writing out the expression which is representing Aka's bill, and we are going to select all that apply. So we have a flat fee of $50 plus we have $25 per hour, and on Monday worked 2 hours, on Tuesday worked for 3 hours. Okay, so first thing, $50 plus $25 per hour, right? So $25 per hour on Monday, which is how much? 2. And on Tuesday, $25 per hour. On Tuesday, he worked how much? 3 hours. Okay, so which one is this one? This is definitely going to be, this is correct. Let's look what other options that there might be. Is this the same thing? Yes, we start at $50 and then this means 25 times 2. Remember, it's the distributive property. So 25 times 2 plus 25 times 3. And that's literally what we have over here. Okay, so this also is the correct answer. The third one, C, no, because 50 is nowhere there. It starts with 50 plus that. Let's look at D. Okay, so if I look at D, if I had followed order of operations and I had done 2 plus 3 first, what would I get? I would get 5. So it could be 25 times 5. So 50 plus 25 times 5 is also the correct option. And then let's look at the last one. It is not starting with $50, with $25. It's starting with 50, right? So writing 25 and then trying to multiply 50 times 2 plus 3 in parentheses, that is not the correct way to write this, because we start with $50 and then you are adding $25 per hour. It is not $50 per hour the way this is being represented over here. So once I have this, now I can simplify, and I have 50, okay, plus 25 times 2 is 50, right? Plus 25 times 3 is 75. So 50 plus 50 is 100 and 100 plus 75 and I get 175 as my answer to this question as to how much does Aika owe the technician. She owes the technician $175. All right. Let's evaluate these symbols, these expressions. And I have two expressions over here, so I'm going to evaluate each of these using the right grouping symbols. Okay, so let's start with the first one. So let's look at this. Do we have, so we always in the beginning, go ahead and write PEMDAS. So we know exactly what to look for. So first thing we need to look for is parentheses or the grouping. So yes, we do have grouping going on over here. Okay, we have grouping over here. So what is 4 plus 5? Because we are doing everything within the parentheses first. And so this gives me 9 squared, right? Because that is grouped. This is grouped 4 plus 5 over 3 times. We have 7 minus 4 and I am going to get 3. All right, then the next thing we're going to do is solve the exponent. Okay, we are going to evaluate the power in the numerator. So the power, what is 9 squared? That means 9 times 9, which is 81. All right, over we have my 3 times 3, which is your multiplication, and when I multiply 3 and 3 in the denominator, I'm going to get 9. And what is 81 divided by 9? My answer is going to be 9. So that was the first one solved. Let's do the next one, and we are going to see that what do we have here? So when we look at this, we are first going to solve. Now, yeah, we do have brackets, but within the brackets, we have the parentheses or the grouping inside. So we are going to start with the innermost parentheses, and we are going to evaluate that first. So I'm going to do 15 minus, so let's look at this. We have 10, right? And we have plus, what is this? This is 1 squared plus 6. And what is 1 squared? 1 times 1 is going to be 1, right? So this becomes 15 minus, and I am going to write it like 10 plus 1 plus 6. So after that, I am going to add, okay, because that is still within brackets over here. So let me put it here. So this is now going to become 15 minus, what is 10 plus 1? I get 11, right? And so this is here, this is 11. And I have plus 6. Now I am going to go, because I only have subtraction and I have addition, so I'm going to go from left to right, and 15 minus 11 gives me 4, and I have plus 6, and when I add the 2, I get 10. And here is my final answer. All right. We are going to use a 4-step problem-solving plan now that can help make sense of problems and persevere in solving them. So let's look at, here's the 4-step plan. All right, so it's saying the 4-step problem solving plan. The first one, identify and understand the task. You're going to read the task carefully and make sure you understand what question to answer or problem to solve. Next, you're going to plan your approach. So you're going to choose a strategy and you're going to plan the steps you will use to complete the task. Next, you're going to solve the problem and you're going to use the strategy you chose in step 2 to solve the problem. And the last part, check the solution. Make sure that your solution is reasonable and completes the task. So let's go ahead and look at this problem. And actually, let's get out of here first. So write and evaluate expressions. And we're talking about money. Thursdays are student days at LSC theaters. Student tickets are $5 and popcorn refills are free. So now I'm going to show you the cost of popcorn, etc. on the next slide. So just bear with me. So student tickets are for $5. Popcorn refills are free. You will buy a ticket and a 20-ounce bottle of water, and you will split the cost of a large tub of popcorn and large candy with a friend. So how much money should you bring? So we are going to go ahead and look at this, and let me give you the cost of everything, which is here. Okay, the cost of everything is provided. So let's look at this one. All right, so we're going to write an expression for the total cost in dollars. So the first thing it asked for was the ticket. Ticket was how much? $5. Okay, so we'll write that over here. The ticket was $5, right? And then you had a drink, which was $5, because it talked about the 20-ounce drink. All right, so plus we have the drink, the 20-ounce one, and this was $5, right? And then it said that you have taken the popcorn and you are going to split the cost of a large tub of popcorn and large candy with a friend. So let's look at the large tub of popcorn. You're going to split this with a friend. So this is, you're going to pay half, right? And for candy, you're going to split with a friend. So you're going to pay how much? Half. If you're splitting it, you are paying half, right? So now when I'm writing this down, so we've got the ticket, we've got the drink, you've got the popcorn, and you're splitting the cost of the popcorn. So what is this going to be? Plus 1/2 times how much? $7.50. And you are also splitting candy. You're also splitting candy, and you are getting plus half of the candy price, which is what? $3.50. Okay, so times $3.50. So this is literally how you're going to first write it out, and then after that we are going to go ahead and solve this. So I'm going to go ahead and do it over here. And we are going to, the original expression is written up over here, okay? And so I have 5, I have plus 5, plus what is half of $7.50? It's going to be $3.75, plus what is half of $3.50 is plus $1.75. And then when we all add all of this, it's going to be $15.50. And so this is my final answer. Okay, and so that's literally what this entire first module is it's just numerical expressions. We are writing numerical expressions from the verbal expressions or for the verbal expressions, and we are evaluating them following the order of operations. All right, you all have a great day, guys.